Good afternoon, everybody. So our method here does two things. It tracks multiple objects, and the second thing is it's in real time. And primarily, we are using the depth image, ignoring the color image, and trying to see how the accuracy is when we do it only with the depth image. So the proposed method has two major features. The first feature is to do a noise suppression. As we know, that cameras induce a lot of noise at the boundary, as well as due to the distance and movement of the object. Okay, so what we try to do here is first use a morphological watershed algorithm, and that would basically identify multiple regions in one depth image. And then we also try to look at overlapping of images, I mean the regions, and try to look at a merged region. So what that means is if you have a human, then we would be tracking the whole human, not the part like hand or leg separately. So, and if the human picks up a book, the book would be tracked along with the human. So, after noise suppression, what we try to do is to optimize the tracking part by using the direction of movement. So, what we try to do is look at excuse me, look at the percentage of pixels that have moved with respect to a given region. So, we identify how what part of the region has moved and the direction of movement, and we can basically use 8 or 16 cardinality, and in the experiments we used 4 cardinality to identify the direction of movement. So with respect to tracking itself, we have a region graph based technique. So the idea is that once you have identified multiple regions in the depth image, each of those regions are assigned as a node in the region graph, and the edges of the graph denote the adjacency to the regions. So the easy thing would be to not try and track the object or the region across multiple links in the graph. The other optimization that we try to do is to take the direction of movement. So if we identify the direction of movement to be in, I'm not able to get the mouse pointer over here on the right side, the region of nodes 1 and 8 or something like that. So those will be the regions that would be identified as possible parts where we need to track. So from the object or the region detection point of view, we accumulate a few frames, like 4 to 5 frames seem to be optimal from the experiments that we did. And the reason that we do is we need to identify the direction of movement. So once we identify the regions, we accumulate 4 or 5 frames and identify the direction of movement, and then we are ready to track. So the tracking is in real time, but we take like 4 to 5 frames, and it also means that the accumulation of frames also means that we are tracking dynamic objects. And so if there are static objects, like if a person is sitting for not moving for several frames, then we are not really tracking that person. So some of the tracking results are shown over here, and it does well with occlusion as well. Now, and when new objects appear or reappear in a scene. And with respect to the various data sets, the detection accuracy is better or comparable to existing algorithm, except in cases where there are like static objects or static humans and they don't move, the accuracy was slightly lower. With respect to tracking, the accuracy was very high. Now, with respect to the time, it was like a few hundred milliseconds for tracking after accumulating few frames. Now the whole thing was implemented on CPU, so if you implement the algorithm on GPU, I think we would be able to have even faster tracking. And intentionally we didn't include the RGB, the knowledge from RGB, but I'm sure that we can improve the tracking accuracy as well as the detection accuracy if we incorporate knowledge from RGB.